I think it's out of control. I think it's not being regulated. I think the wrong things are being regulated. And the idea that a single person should be driving around in a 3 or 4 ton vehicle is beyond ethical. It takes so long to get patents in through universities and through commercialization that it really begs into question sometimes how helpful will that be in the future in reality when OEM product cycle times are not getting longer, they're getting shorter. And the automotive companies fundamentally made that assumption and they planned around it. And they didn't keep an eye on it until it was quite late in the day, quite late in the cycle to be saying, we just don't have the demand for this. There's all kinds of applications that the automotive car is going to go towards, just like the way the phone a long time ago was just for making calls, and now you do so many things on it. Hey everybody, and welcome to another episode of Future Engineering Bets. I'm Fred Warner, and we talk about advanced engineering and where capital, investment, and technology are likely to progress over the next 5 to 10 years, particularly aimed at capital investors, boards, and people that are involved in steering companies. Today, I've got a number of topics we're going to go through that have been uncovered with conversations in recent podcasts with the likes of Richard Hopkins, former Red Bull head of operations for many years, now working in technology and bringing technology from universities into the commercial space. There's Mark Grain of the Extreme H, the hydrogen fuel cell motorsport project. There's Mark Preston, the Formula E team principal. And there's Ian White of the amazing McMurtry record-breaking car, super lightweight. Lots of interesting points come up. So topic number 1, EV weight. I think it's out of control. I think it's not being regulated. I think the wrong things are being regulated. Let me cut to the chase. The average EV is between 300 and 500 kilograms heavier than its equivalent petrol counterpart. That's a massive increase in terms of the weight going through the road, in terms of the materials that go into making the car in the first place, in terms of the wear on the tires and the components, and the wear on the roads as a result. Now, not just that, but the opulence. You know, we are looking at EVs that often weigh 3 to 4 tons, particularly with the larger SUVs. And the idea that a single person should be driving around in a 3 or 4 ton vehicle is beyond ethical. Now, we all like sports cars. Well, I certainly do. And I'm not going to say that I am totally bought into everything being EV, because I am not. But the idea of EV allowing people to take liberties with ethical, sustainable engineering by having excessively large vehicles with excessively out of control weights that are damaging the roads, that are consuming way more materials than their equivalent petrol car did, is unethical. And I do think something needs to be done about it. This is where the benefits in terms of the 7Q method, you start with your why, just like Simon Sinek says, but the benefits of having EVs in the first place are not so that everybody can quadruple the size, weight, and opulence of their cars. So in terms of what are they doing, they're focusing on high-end, large, heavyweight vehicles for people that want a certain kind of thing. But the taxman is funding this through tax incentives. That means somebody can run around in a 3 or 4 ton vehicle and can be considered green by our government, when at the same time somebody can be driving around in a vehicle a third of the weight, but a petrol car, and considered to be not green. It doesn't make any sense. Topic 2. Speaker Richard Hopkins really brought about an awareness that taking IP from the university stage to commercial realization, although we have maturity of it in, I would class as the Western Hemisphere, and Australia's trying to catch up, it's not very mature when 95% of IP, intellectual patents, have never been commercialized. I have worked in a company where we had a patent wall, and I remember standing in front of it, looking at them all and thinking, none of these are making any actual money. Being obsessed with patenting is understandable given large corporations and the battles they have with one another as they build tech and protect tech. The little companies really struggle with the cost of patenting and the ongoing maintenance of patents, especially as if somebody decides to choose your design and cheat and take it anyway. You have to take them to court. The onus is on you rather than the onus being on the people breaking the patent. Now, to add that in terms of cadence of delivery, it takes so long to get patents in through universities and through commercialization that it really begs into question sometimes how helpful will that be in the future in reality when OEM and product cycle times are not getting longer, they're getting shorter. If you take the automotive industry, there's going to be a pressure to do a product cycle within 2 to 3 years. Now, technology and technology development isn't the same as product development. So technologies might take 10 or 15 years to develop and then feed into a product cycle. But the same pressure is going to be on technology. Companies are going to be stepping up faster and faster. Where does that leave the university and what function are they going to fulfill when there's an acceleration of commercialization of technology and they are on the sidelines working very, very slowly? Now, I want to talk about active aero and the McMurtry Spearling vehicle that I spoke to Ian White about in my previous episode really highlights the use of using suction to take a vehicle and suck it to the ground. And they've even proved that they can suck their vehicle to a ceiling whilst it's stationary because their vehicle generates 2 tons of downforce. And the vehicle doesn't weigh any near 2 tons. So it can stick to a ceiling and literally stay there. Now, this kind of active fan technology really is something that I think we should be looking at further in motorsport to make it go further. We always talk in motorsport about how the dirty air of the car in front affects the car behind, but we don't really come up with many ways to fix it other than reduce the amount of drag coming off the car, which is then to trim the aerodynamics. Well, what if we can use active fans in a more proactive way and reduce the amount of active aero bodywork even more? Now, when you look at the applications in cars, in automotive, can our cars go around sucking themselves to the ground? Well, maybe not as much as the Spearling, maybe not generating 2 tons of downforce. But what it does show is that if vehicles were to have some elements of active fan technology for braking, for cornering, and other safety situations, how is that not a place of interest to develop further? I'm really keen when I talk to the motorsport people to always go through their whole way of thinking in terms of getting problems, solving them fast, the pressure's on, there's a timeline that can't be missed that isn't present in most businesses. And we look at motorsport with envy when you're outside of motorsport. I worked in motorsport and I've worked outside of motorsport. And people see it as a holy grail of what to achieve. It is achievable for anybody, but you have to be really purpose driven. You have to get your teams in a real alignment that isn't present in most companies. And people need to know exactly what they're delivering and when they need to deliver by. But it's not delivered just through hitting people and kicking people. These people are motivated to deliver. They want to deliver. This is competition. And that doesn't really feel present in a lot of companies because the only thing you're competing for is more profit for shareholders. That doesn't really help motivate a workforce very well in a way it does in motorsport when there's a competition to it. Should we be looking at how we motivate people across the board to achieve greater goals without it all being focused purely from their sake on profit? Delivery is all about momentum and tempo. And this is what Formula One teams build in. They get very aligned, very focused on what they're doing. They get a tempo, a rhythm of delivery, and they push and they drive and they overcome the blockers. When you talk about corporations and companies outside in the normal world operating both in advanced engineering and in other sectors, there tends to not be the urgency, there's not the motivation, there's not the focus. They're just carrying too many responsibilities, too many projects. There's not a prioritization. And in the end, everything drifts slowly forwards rather than being pushed into more value stream operated functions that can deliver quickly and they're motivated to do so. Now, my next topic today is looking at corporate restructuring and program restructuring. So in automotive, we've seen some of the largest write-downs in history. Ford have written off billions for their programs, stopping cars. Honda have written off one of their major EV programs. It's across the board. Now, where did it go wrong? We understand that there's a difference between what the market is doing or was doing and what the regulators were pushing companies, particularly in the automotive sector, to do. But just because you were being pushed into something doesn't mean the market was going to buy. And the automotive companies fundamentally made that assumption, and they planned around it. And they didn't keep an eye on it until it was quite late in the day, quite late in the cycle, to be saying, we just don't have the demand for this. Equally, the automotive companies are taking fines in many places when they don't sell the correct amount of cars, particularly in the UK. And Europe has slightly different regulations, and there are some relaxing of rules going on in Europe at the moment that aren't yet being considered or enacted in the UK. But this does bring into question the approach, both from a capital allocation and a program delivery in the automotive space, of how are you going to do this in the future? Yes, this is an uncertain transitionary period between the classic internal combustion engine driven car and the EV, but the automotive vehicle is changing rapidly anyway. We're becoming software defined. It's going to be software controlled, self-drive, safety focused, infotainment focused. Maybe it's going to be charging your house up at night. Maybe you will be taking energy off it at night, and maybe you'll be putting it back in during the day to help with grid management in the future. There's all kinds of applications that the automotive car is going to go towards, just like the way the phone a long time ago was just for making calls, and now you do so many things on it. The car could end up being one of those for you in the future as well. So how are OEMs going to change their approach to the capital allocation and the stage-gated mechanisms that take them from having an idea through to having a car rolling off a production line? When you look at the benefits of what they've done, let's say Ford's 20 billion write-down, these aren't things that surely are sustainable for these companies at the same time as the Chinese companies coming in at a rate of knots, with new car companies popping up, funded by the Chinese government apparently every day, and taking the automotive market share from the Western, the European, and the American car manufacturers. Things are changing rapidly in this space, and it does require a rethink of the approach towards capital allocation, program governance, and when you do and don't proceed with design changes. So there is some of the thoughts that I've taken from some of my recent podcasts. I will see you on another Feb episode. My name is Fred Warner, and Future Engineering Bets is about advanced engineering and where capital allocation and investment will be going in the future. See you on the next show.